Hello and welcome to this fifth video in our lecture on user authentication with passwords and biometrics. In a previous video, we discussed salting, which is the process of adding a fixed size random bit string to the password before it is hashed and stored in the system password file. In this video, we discuss the advantages of salting. First, we're going to ask whether salting helps with the type 1 attack we discussed in a previous video. And remember, these attacks were brute force attacks on a particular user account. So this is a situation where someone is targeting a particular username and just logging in, impersonating that person, and trying, all possible passwords one after the other. So does salting the password help in this case? I want you to pause the video and answer that question on your own. So the answer is that salting does not help in this case, because since you're just inputting as the attacker the password into the system, whether there is a salt or not, you're still going to have to try and get every password hashed by the system. And whether there's a salt or not, it's not going to slow you down. You don't know the salt, you don't need the salt, it's kind of invisible to you as the attacker. So in this case, salting um, does not help. So how about the second type of attack, which was the offline dictionary attack? So this is the attack where you obtain the password, the system file with all the passwords and all the, all the hashed passwords, all the user IDs and the associated salts. And so the question is whether, and so the attacker in that attack basically does a forward search attack by hashing all passwords and then see if there's a match in the system file. So the question is, how much work do you have to do without salting, and then how much you have to do with salting, and is there a difference? So I want you again to pause the video and think about whether salting helps protect system against such attacks. So let's look at the situation. So remember that in this attack, the attacker has copy of the system password file. And remember that in each entry of this file, we have three elements. So we have the user ID, we got the salt that was randomly assigned to that user, and then we have the hash code of the user ID concatenated with the salt. So if there was no salting used in this system, then the attacker would have to try the number of passwords. So the set of all passwords, say the size of that is P. So without salting, the attacker basically has to hash P passwords, and then for each one of them does a lookup um, to see if any one of the hash codes in the system file are stored in their pre-computed file. Now with salting, things are a little bit different because there's still P passwords for the attacker to try, but now every password has associated with it some B bits, say, which is the length of the salt. So it doesn't help the attacker just to hash passwords. It must hash each password together with a salt. The problem is that in this kind of attacks, the attacker has no way of knowing in advance which user ID they're going to be able to crack. Remember, they are just searching on hash codes and then find a match anywhere in that file. And so they're basically checking a whole bunch of users at once, and they don't know which one is going to work, if any. And so this is the difficulty here. So the only way this is going to work is assuming they have the file and they know all the salts, they have to try every single salt because they have to add that, concatenate that to each password before they hash it. So the bottom line is that for every password, the attacker is going to try every salt value in the file. Okay? So it doesn't matter how long the salt is, if there are n users in this file, then the attacker is going to hash every password and try every one of them with every single one of the n salt values. So the amount of work in this case is going to be p times n. And so if you have a system with a lot of users, in general, this would be good for the attacker without salting, because the more users there are, the more likely or the quicker they are to find a match between the hash code in the file and the one they compile. On the other hand, with salting, it's much more complicated, or at least it's much more time consuming, because the computation is multiplied by n, which is the number of users. And the more users in the password file, actually, the slower the attack is going to be. So if we have 1,000 users, say in your company's password file, then the attack will be 1,000 times slower. So the bottom line is that salting is very efficient to make offline dictionary attacks harder. So it's a pretty good security mechanism, and that's why it's used quite a bit. It's definitely been used in every Linux and Unix systems for a long time. So let's think about some other ways that salting also helps with security. So we already talked about this one just now. Second advantage is that it also prevents duplicate passwords for showing up in the password file. So just in case users use common passwords, if that is the case, then it's pretty likely that two users will have picked the same common password. And without sorting, those two passwords would hash to the same values, and then the duplicates in the hash code would easily point the attacker to the easy to break passwords. But with salting, this does not happen, because even if two users pick the same password, they will have a different salt associated with their account, and therefore they're going to have two different hash codes. So that's definitely helping to slow down the attacker or make the attack harder. And also another side effect is that if a user uses the same passwords in different systems, and the attacker has access to the password files of these different systems, they will not be able, just by looking at the file, to find out that the user is using the same two passwords, because they will have different salt or random values in each file, and therefore the same password again for a given user will not appear as the same hash code in the different files. So these are some of the advantages of salting. Just realize salting does not prevent the attacker from proceeding. It just slows them down. Okay? And so the bottom line on password is that password attacks are pretty easy compared, say, on attacks on encryption. And the bad part is it takes only one weak password to break into a system. So, for example, if we have an outsider who's able to break the password of an insider or regular user, and then they do a privilege escalation on that user, which means basically using a flaw or a bug in the system, they manage to get from the privileges of the regular user to the administrator privileges, say, which is the worst case, then they have potential for a lot of damage in the system. And unfortunately, all this requires is one weak password in the whole entire organization, because attackers will find the weakest passwords right away. And this is unfortunate because these attacks are very common. That's because users often choose bad passwords. It's also because social engineering attacks are pretty easy and very common to carry out. So the bottom line is that the attacker truly has basically all of the advantages in his situations. It looks like we said before, the weakest link is what the attacker is going to take advantage of. And the bottom line is that passwords are often the weakest link in addition to the users of the system. Um, so what are you to do? Well, as a user, you might want to make sure you pick a secure password. Of course, that's not enough for the security of the system, since a single other user picking a bad password will weaken the whole system. But personally, everybody should take as safe a password as possible. So that's why there's a whole bunch of websites out there, and you could try this one where you can check the strength of your password. Now, you should be careful with these kind of tools, obviously, because first of all, it's not clear that they actually measure the real security of your password. If you look at this one, you'll see it has a bunch of rules about adding points and subtracting points according to some formula to the strength of your password based on the character that you use. I want you to try it and see if you can find a password that looks pretty weak to you but still ends up with a high score. And of course, another even more serious security issue is, are you really willing to enter your password, the one you're really using or planning to use, into this website? Is this website secure? What does it do with your password? And so on and so forth. So the bottom line is that passwords are used everywhere to this point, but they are definitely a big security problem. And they are not going to get any stronger anytime soon. So it's very likely, if we keep using password, that this security problem is going to persist. So if you're working on a security team within your company, you will be using a bunch of these password cracking tools in order to test the security of the passwords in your user population. So I haven't tried all of these, but I did look at the Lovecrack password cracker, the LC7. They have a nice little video there, about 5-minute video that shows how to use this system, basically to audit your password file and therefore try to crack and find weak passwords in there. I think John the Ripper is a very famous one that's been around for a long time. I haven't tried this one, and so on and so forth. So the Rainbow Crack is one that uses a famous technique for cracking passwords called rainbow tables, and that's another example of a space-time trade-off where the attacker does a lot of pre-computations that they store in tables, and these are called the rainbow tables. And then using this technique, they can speed up password cracking in some cases. So this concludes our discussion of user authentication with passwords. Just keep in mind that passwords are not a secure user authentication mechanism. So in the next video, we're going to talk about a new class of mechanisms. Well, not new, but different, and mechanisms that are being used more and more in today's systems. And these are biometric systems.